Hello everybody, welcome into another lesson. So today we are going to discuss powers of monomials. We are going to basically do powers to powers. So let's say I have some arbitrary variable or constant, a to the m power. I have a to the m to the n power. If you have a power to a power, you just multiply the two powers together. Keep the same base, you just multiply the two powers together. Now let's say I have more than one variable or a constant in a variable inside the parentheses raised to a power. You take each constant or variable, you raise it to that power. So ab to the m power would be am bm, b to the m. And we'll get into some examples here. So powers to powers actually aren't that bad. Let's say we have c to the second to the third power. So we have c to the second to the third power. You're just going to take the two powers, 2 times 3, and multiply them. You'll get c to the sixth. So the answer you should get is c to the sixth. Alright, let's see. We have x to the seventh, that quantity, to the fourth power. Well, you're going to keep the same base, x, but you're going to take the two powers, 7 times 4, multiply them, which should give you x to the 28th power. So the answer would be x to the 28th power. You do that whenever you have a power to a power, you just multiply the two powers. Alright, let's do one more. How about if we had -2 times k to the fifth to the sixth power? Well, now you have a constant on the outside. Order of operations dictates we deal with the exponents first. So you're still going to have -2, but you're going to deal with the k to the fifth to the sixth. So again, you're just going to deal with k to the fifth to the sixth first because your exponents come first. Whenever you have a power to a power, you just multiply the two powers. So you'll have k times k to the 5 times 6, which would be k to the 30th. So you'll have -2 times k to the 30th, which would just give you -2k to the 30th power. And that's the answer you get, -2k to the 30th power. I suppose we could do one more like it. -5 times the quantity of a to the fourth to the third power. So again, you're going to leave your constant alone for a minute, but order of operations dictates we deal with the exponents first. So you'll take a to the fourth to the third power. Well, you'll keep your base a, you just multiply the 4 times 3, you would get a to the 12th power. Which now you can do -5 times a to the 12th, which would just give you -5 a to the 12th power. And that would be the answer you get, -5 a to the 12th power. Alright. Now let's move into the second type of problem here. Let's say we have 7a to the second power. Well, if we recall, you take each term inside the parentheses, the constant and the variable, you would raise the 7 to the second power, you would raise the a to the first power. 1 times 2 is a to the second. So you're going to have 7 to the second, a to the second, which 7 to the second is 49. So you will have 49 a to the second power. That's what you would get. Because you take each term, the 7 and the a, you raise both to the power that's on the outside of the parentheses, leaving you with 49a squared. Alright, let's see. We have negative 2t, that quantity, to the fifth. Well, again, you're going to take each term, the negative 2, you'll have negative 2 to the fifth times t to the fifth. Because you take each term inside the parentheses, raise those to the fifth power. Well, negative 2 to the fifth, that's going to be negative 32. Then you just have t to the fifth. So the answer you should get should be negative 32 t to the fifth power. Alright, we have 5x, that quantity, to the third power. Well, you're going to take your 5, raise that to the third power, then you'll take your x, also raise that to the third power. So you have 5 to the third power times x to the third power. Well, 5 to the third power, that's 125. Then you just have times x to the third power, giving you 125x to the third power. That's exactly what you would get. So you see, these really aren't that bad, quite honestly. They're really not that bad. Now let's spice it up a bit. We have 3a squared b, that quantity, to the third power. So you're going to take each term, you're going to take your 3, raise that to the third power. You'll take your a squared, raise that to the third power. Then you'll take your b, raise that to the third power. Well, now let's go ahead and deal with our exponents. 3 to the third power, that's 27. A squared to the third power, that's a to the 2 times 3, which would be a to the 6th. Then you got b to the third. So the answer you should get would be 27a to the 6th, b to the third. Because you take each term, the 3, raise that to the third power, take your a squared, raise that to the third power, then take your b, raise that to the third power, giving you 27a to the 6th, b to the third. Alright, let's see. We got 2x squared y to the fifth. Alright. So again, you take each term inside of here. So you'll start with your 2. You'll raise that to the fifth power. You'll take your x squared. You'll raise that to the fifth power. Then you'll take your y and raise that to the fifth power. So now we do with our exponents. 2 to the fifth, that's 32. So we have x squared to the fifth power. You would just take your base x, multiply the 2 times 5, you would get x to the 10th. Then you'd have y to the fifth power. So the answer you should get would be 32x to the 10th y to the fifth. That's exactly what you should get by the time you deal with taking each term to the fifth power. Alright, what we have? 2r cubed s to the fourth, that whole quantity to the fourth. Okay, so we have 2r cubed s to the fourth, that whole quantity to the fourth. Take each term, the 2, start with the 2, you'll raise that to the fourth power. Then you'll take your r cubed, you'll raise that to the fourth power. Then you'll take your s to the fourth, you're going to raise that to the fourth power. So now we deal with our exponents. 2 to the fourth, that's going to be 16. Then we have r to the third to the fourth, so you'd have the base r. Then you'd have 3 times 4 for your power, which would be the 12th. And then you would have your base s. You would have s to the fourth, which would be s to the 4 times 4, which would be s to the 16th. So the answer you should get is 16 r to the 12th s to the 16th. That's exactly what you would get. Alright, let's say we have something like this. 2x, that quantity squared, times 2x, that quantity to the fourth. Well, when you have a situation like this, you're still going to take each term to the powers. You're going to have 2 to the second power. I would create brackets because that's going to make your life a lot easier. You'll have 2 to the second power times x to the second power. Put that in brackets. Then create another set of brackets. You'll have times 2 to the fourth power. Then you'll have x to the fourth power. Okay. Well, we've dealt with the power on each of these 2 terms of the multiplication. Alright. If we recall from yesterday's lesson, if you have the same constant or variable base, whenever you multiply, because you're going to have 2 to the second times 2 to the fourth, let's go ahead and collect the like terms. You'll have 2 to the second times 2 to the fourth. All that times the quantity of x squared times x to the fourth. So group your like variables and constants together. What you have to do whenever you're multiplying the same base, you add the powers together. So this would go to 2 to the 2 plus 4 times the quantity of x to the 2 plus 4. Which we know 2 to the 2 plus 4, that's 2 to the 6th, times the quantity of x to the 2 plus 4, which is 6. Well, 2 to the 6th, that's going to be 64. X to the 6th is just that. So the answer you should get is 64x to the 6th power. That's exactly what you should get. And I got more examples like this. Alright. Let's see, we have 3c to the second power times 3c, that quantity to the third power. So what you're going to do, create a set of brackets, take your first term, 3c, you'll raise each term the 3 to the second power and the c to the second power. Now you've dealt with your second power with the 3 and the c. Now you're going to deal with the third power with your 3 and c. Create a second set of brackets. You'll take all that times 3 to the third power times c to the third power. Now the best thing you can do next, because you can only multiply like terms, like, you know, the same base. They have to be the same base. So you're going to end up having 3 to the second times the quantity of 3 to the third. Then you'll have that times c to the second times c to the third. Well, again, whenever you multiply a constant or variable by the same base, you just add the sum of the powers. So 3 to the 2 plus 3 is what you would get, times c to the 2 plus 3, which is going to equal 3 to the 5th c to the 5th. Now I just need to find out what 3 to the 5th is in order to get all this. So what is 3 to the 5th? 243. That would give you 243 c to the 5th. So the answer you should get by the time you're done dealing with all your powers is 243 c to the 5th. And I could do one more example like this. Alright, 3x squared y, that quantity to the third power, times 2xy. Okay, so again, what I would do first, create a set of brackets and start with your first term of the multiplication problem, the 3x squared y, that quantity to the third. You'll take your 3, raise that to the third power. You'll take your x squared, raise that to the third power. Then you'll take your y, raise that to the third power. See why I said create brackets? Because you're going to have parentheses inside the brackets. Now we've dealt with the first term. You're going to take your second term. You're just going to have times 2xy. Nothing more we can do with that right now. So now let's go ahead and deal with our exponents inside the first term. You'll have 3 to the third, which is going to be 27. You'll have x to the second to the third power. Well, you would take x to the 2 times 3, which would be x to the 6th. Then you just have y to the third. All that times the quantity of 2xy. Now when you multiply, of course, you'll take your 27 times 2. You multiply the constants normally, you would get 54. And then whenever you multiply again, whenever you multiply variables of the same base or constants of the same base, you just add the sum of their powers. So x to the 6th times x to the 1st would be x to the 6th plus 1, which would be x to the 7th. And then you have y to the 3rd times y to the 1st, which would be y to the 3 plus 1. That'd be y to the 4th. So the answer you should get would be 54x to the 7th, y to the 4th, by the time we've done everything. So whenever you have a power to a power, you just take, all you're going to do literally is you're going to take the base and multiply the two powers, and then you'll have the new power. So if I had x to the 6th, that quantity to the third, I would get x to the 18th. Or let's say I have more than one term raised to a power. I take each term inside the multiplication and raise each term, whether a constant or a variable, to that power on the outside. That's really all there is to it. So on the next lesson, we're going to multiply polynomials by monomials. So I hope everyone has a good night. Take care.